Hello, today we're going to talk about mean absolute deviation. And it's not the first time that we've discussed mean absolute deviation, so I'm not sure if I should call this an introduction because you've already been introduced to it. But we're going to review it and go a little bit deeper. All right, so let's take a look at a sibling survey. All right, Cayenne surveyed two groups of people. He asked them how many siblings they each had. The average, or the mean, number of siblings from the first group was 2. The average mean, or the number of siblings from the second group was 2. So was the data basically the same? We'll have to look at the data to be sure. So here's the data from the first group. We have 1, 2, 3, 2, 1, 2, 3, 2. So this kid had 1 sibling, this kid had 2 siblings, 3 siblings, so on and so forth. Here is the data from the second group. This kid had 0 siblings. Actually, 1, 2, 3, 4 people had 0 siblings, and there were no people that had 0 siblings in the first group. 6 is my highest number here. The highest number here is 3. So the data sets definitely are different. So was the data basically the same? No, the data from the second group was much more spread out from the mean. So the mean absolute deviation is a measure of how spread out the data is from the mean. So for example, here is a dot plot, line plot of pets. So here's a survey of one group of people and a survey of another group of people. And as you can see, the data is different. So my mean for the first group is here. And you can see this is the spread. And here's the mean for the second group, and there's the spread. So the mean absolute deviation tells us how far the data is from the mean on average. Oh, that mess. So basically this says it talks about the variation. So mean absolute deviation talks about how the data varies. Here's another example. We have the mean here and the mean here, and here is the spread. So if there's a large variety of data, which is very spread out over a large range, the mean absolute deviation will be a greater number. All right, so here's an example. When you place Cayenne siblings data on a dot plot, you get a visual representation of how the data varies. Okay, so here's a visual representation of how it varies. So the second group will have a greater mean absolute deviation because, as you can see, the data varies greatly, which tells that the data is more spread out from the mean. So how do we calculate the mean absolute deviation? All right, step 1 is find the mean. And I'm sorry that it did this. It does this when it converted over to this platform. I apologize. So for the first group, we add up all the numbers and divide by how many we had. We had 8 people in the survey. We got 2. And then the second step is to find the absolute distance from the mean. So we're finding the absolute value from the mean using that the value. So each value that we have in our data set, we're going to subtract it from the mean and take the absolute value of that number because we just want the distance. We don't want negative values or anything like that. For example, if we have 1 minus 2, we don't want negative 1. We want 1 because that's the actual distance from the mean. So that was the example that I just gave, and so on and so forth. So these are 0 steps from the mean, 1 step, 1 step. And then we're going to find the average of those distances. So that's 1 plus 1. Should we have 8 just like we had here? So 1 plus 1 plus 0 plus 0 plus 0 plus 0 plus 1 plus 1. And we get 4. Divide that by 8. So the average distance of each, and this is just the average, so the average distance of each data set from the mean is 0.5. What is the MAD or the mean absolute deviation for the second group. Again, we find the mean, and we find the absolute deviation from the mean. So here we have 2. This is 1 step. This is 2 step. Here we have 2, 3, and 4. We add up all those values and divide them again by 8. And so now our average distance from each step is on average 2.2 from the mean. So going 2.2 in this direction and 2.25 in this direction, 2.25 in the other direction. So the first group had less variation, and we can calculate the mean absolute value of 0.5 to represent the variation of the data points compared to the mean. The second group had more variation, so we can calculate the mean absolute deviation of 2.25 to represent the variation. All right, so here we have tickets purchased, 3, 4, 9, 8, 2, 6, 3, and 5. We're going to find the mean first. Add up all the numbers to get 40, divide by how many numbers we have. We have 8 and we have 5. Then we're going to take 5 and subtract it from each value. So it's going to be 3 minus 5, and we get negative 2. However, we want the positive, or the absolute value, and so that gives us 2. 9 minus 5, 4. 2 minus 5, negative 3, turns to 3, and so on and so forth. So here, 5 from 2 is 3 steps, 2 steps, 1 step, 0 steps, 1 step, 3 steps, and 4 steps. So we're going to find the average of those distances, divide it, find the average, and we get 2. So now we know how to calculate mean absolute deviation. It's the measure of variation, which tells us how to spread out the data from the mean. So let's do one. So why don't you pause the video and you try to find the mean absolute deviation of this data set. So when we find the mean absolute deviation, the first thing we do is find the mean. That's the first step. So we'll say here, mean. And the mean is just adding up all the values and dividing by how many we have. We have 1, 2, 3, 4, 5, 6, 7, 8. So that's 10 plus 20 plus 20 plus 10 plus 40 plus 50 plus 70. That gives me 220 divided by 8. And I get 27.5. So the mean is 27.5. All right, now I want to find the distance. So it'll be 10 minus 27.5, 20 minus 27.5, and I went ahead and wrote it out so we can save a little time. And so we have 10 minus 27.5 is the absolute value of negative 17.5, which is positive 17.5, and so on and so forth. Up here, I did not write the absolute value out because 50 minus 27.5 is going to give me a positive anyway. The absolute value is just to remind you that I am finding the absolute value. It has to always be positive. And when I did all of that, I added 135, and then 135 divided by 8 is 16.875. So on average, each data plot is about 16.875 points away from the mean value of 27.5. All right, let's try one more. Find the mean absolute deviation. The first thing I want to do is to find the mean. So I have 1, 2, 3, 4, 5, 6 values. So that's 2 plus 3 plus 5 plus 3 plus 8 plus 9 divided by 6 gives me 5. So the mean is equal to 5. Then I want to take each value and subtract it from the mean. Oops, this is 9 minus 5. And so So that's going to be the absolute value of -3. That's going to be the absolute value of -2. That's 0. It's going to be the absolute value of -2. It's going to be just plain old 3, or the absolute value of 3, which is 3, and 4. So that's 3, 2, 0, 2, 3, and 4. I'm going to add those up. So it's 3 plus 2 plus 0 plus 2 plus 3 plus 4. And divide that again by 1, 2, 3, 4, 5, 6. And I get 2.3. So the MAD, or mean absolute deviation, is equal to 2.33. Repeat. Alright, and so that means on average, each data point is about 2.3 or 2 1/3 points away from the mean of 5. And I hope that this helps.